So today we will discuss a very interesting topic, that is quadratic equations for class 10 and 11 without the complex number part, right? This is for class 10 and 11 CBSE, but in 11 they have the complex number part also, but before that the 11 syllabus has this in quadratic equations part. We will not discuss the complex part of it, complex number part of it, we will discuss later. So quadratic equations, so we all know what is quadratic equations. You have obviously learned in class 7, 8, 6. So a function which looks something like this, ax square plus bx plus c, this is known as a quadratic equation because the degree of this polynomial, how much? Raised to, right? This has degree 2. Now as this is degree 2, it is known as quadratic. If it would have some other degree, then other type of polynomial, then these are known as the coefficients. Now over here, if we try to analyze, a, b, c are just three real numbers, three numbers actually, obviously real, we are not talking about complex. So a, b, c are three numbers. So a is the coefficient of x square, b is the coefficient of x, c is the constant, right? C is the constant. So this is a preliminary lecture, so we will just look at what is a quadratic equation and how to find the roots. So it will be a more or less a complete lecture in itself. So this is a quadratic equation. So if we try to analyze this quadratic equation, this equation according to the fundamental theorem of algebra, how many roots does it have? Obviously 2 roots, because power is 2 real roots. Now we need to find those alpha and beta. That is a hard task, right? Because if we can't do the factorization by middle term, then it is very problematic in nature. So what we will do, we will analyze. Suppose we have some function x square minus 2x plus 1. This is a well-known formula of x minus 1 whole square. So this is x minus 1 whole square. So if we put this to 0, then we can find the roots, and both the roots are 1. Both the roots are 1. But if we have a slightly complicated quadratic equation, suppose this is x to the power 4 plus x to the power 2 plus 2x minus 1, then what to do? It is problem, because then if we compare this to this, then a is 1, b is 2, c is minus 1. Then Sridhar Acharya, a mathematician, well before 1700 years ago, close to that range, gave a very exciting formula to find the roots of a quadratic equation. This is known as the quadratic formula. If we will do another video on proving that equation, but we will just use the formula over here. So if this is the quadratic equation, then how to find the roots? Just put this to 0 and find the coefficients by comparing this with the equation. That is the normal equation, the general one. So the two roots, alpha and beta, we are naming the two roots because there are two roots according to the fundamental theorem of algebra. Okay, two roots. Now this has some very good formula. This is a formula which tells x equals to minus b plus minus some d by 2 of a. Now what is d? Root d, right? So the alpha is minus b plus root d by 2a, and the beta is minus b minus d by 2a. So these are the two roots. Now what is d? You will d is a very special type of constant function, right? Because it is a function of constants. It depends on the constants of the quadratic equation. So this is known as d or discriminant. Discriminant. Okay. Now what is this b? This b and this b is same. This b, a and this a is same, c and c. So b square minus 4ac. This is the discriminant, right? So for this equation, we will find the discriminant. B is 2, minus 4 into a is 1 and minus 1. So it is 4 plus 4, this is 8, which is greater than 0. Okay. Now there is one condition. If this d is greater than 0, likewise in this case we have got 8 greater than obviously 0, then the roots, this alpha and beta, are real in nature. Means they are real numbers. If d is less than 0, these roots are complex, which is in the 11th class part, are complex, which is not in 10 syllabus, right? We will not analyze, just you have to know for the 10 standard people that this is complex, not real or not real, right? Now there is a third condition, right? There is a, if write this first, there is a third condition. There is a third condition, you have to know there is a third condition. The third condition is d is 0. That means this condition tells the roots are equal. The roots are equal. That means the roots are both are equal. In the first example we have told x minus 1 whole square equals to 0. Then x equals to 1 comma 1. Here the roots are equal, 1 and 1. In this case the discriminant is 0. We will find later. Okay, write this thing down. Now we will find the roots of this equation. We have found a discriminant to be 8 for this one, for this equation. So the alpha is minus b, b is 2. So minus 2 root 8 by 2 into 1, and beta is minus 2. Beta is minus 2 minus root 8 by 2. If you do the calculations, and alpha is coming minus 2 root 2, so minus 1 plus root 2, and this is coming beta is minus 1 minus root 2. These are all real numbers, right? These are all real numbers, belongs to the real number. This is real, right? So this is a very short video in itself, because I am just introducing how to use this formula, a quick checkbook on how to use this formula to get a root if you want for this type of equations. These are very preliminary aspects of class 10, and also in 11th CBSE and ICC, and these are also there. Okay, so thanks for watching. Subscribe to the channel if you want. More videos will be uploaded. You can check also the other playlists in the chemistry and the physics part, because the best faculties are all obviously teaching over there, and these are all free, right? These are all free and helpful to you in this YouTube, and we will be constantly updating our materials and try to analyze what the best suits for the students, right? Okay, thank you.